In this video, we're going to talk about the differentiation rule. We have learned about the derivative of the function before, and it's going to be using the limit definition. And we have learned some formula that we study, like dip constant equal to 0, dip the power function, dip x to the r equal to r, x to the r minus 1, ddx of x equal to 1, ddx of root x equal to 1 over 2 root x, ddx of 1 over x is negative 1 over x squared, and you have dip e to the x is e to the x, dip sine you get cosine, and dip cosine you get negative sine. Okay, so in this lecture we're gonna talk about the constant multiple rule, the sum and the different rule, and product and quotient rule. So in this lecture I'm gonna cover that, and in the next lecture I'm gonna cover about a derivative of the trigonometric function and the chain rule. Okay, so today we're gonna discuss first about the constant multiple rule. The constant multiple rule turned out to be the one simple rule that you see that sometimes you get the constant multiple of a given function f. Okay, so this guy you have the constant c, and you see that when you have the constant multiply with the function f, you'll be able to pull out, or you just ignore all the constant. Okay, so you just ignore the constant and you just pull this one out, and you just differentiate only the function f. Okay, in this case, like a 5x cubed, so you're gonna be able to move 5 outside. Okay, so you move 5 outside, and you're gonna get ddx of x to the third. So in this case, you will get 5 times 3x squared, or you may multiply this one to be 15x squared. I do this one step by step for you. However, I expect you to be able to go from here to 15x squared automatically. Okay, so you just have 3 multiplied with 5 and kind of get the answer quickly. Okay, the next one, you see that you have multiple of negative 2. So this one you may just think about ignore negative 2, so you get negative 2 and ddx of e to the x. So in this case, it's going to be negative 2e to the x. Okay, and you have 1/3 here as a constant multiple, so you will obtain 1/3 outside, and you have the dx of cos x. So it's going to be dip cos, it's going to be negative sine x. And this will be your final answer. So this guy is called the constant multiple rule, and you're gonna hear me say that, hey, you just use constant multiple rule. It's not product rule. Okay, so this one is called constant multiple. It means that your function is a multiple of a constant. So it's going to be the product between constant and function. The second one will be the sum and the different rule. Okay, so you have fx and gx are differentiable function. So you're gonna dip the sum of two function fx and gx. So this guy will turn out to be just, you'll be able to differentiate this guy term by term. So it's gonna be dip fx plus dip gx. Similarly, for the difference between two functions, you have d dx of fx minus gx. So it's going to be the difference of derivative of fx and gx. So you basically just dip fx minus dip gx. For example, if you have fx equal to x cubed plus sine x minus pi, for this guy, you can differentiate f term by term. So it's going to be dip x cubed, so you get 3x squared, dip sine x, so you get cos x, okay? And dip pi, you get 0, so you get minus 0. So you get 3x squared plus cosine x. Now you have gx equal to x to the fifth plus 2e to the x minus 4 root x. So you have g prime x, okay, dip x to the fifth, so you get 5x squared, 5x to the fourth, sorry, and you differentiate 2e to the x, so it's going to be 2e to the x, okay? So just like I said, ignore 2 and you differentiate e to the x, and you differentiate 4 root x, and I taught you before that when you differentiate root x is going to be 1 over 2 root x. So please memorize this thing. Okay. So in this case, your final answer turned out to be 5x to the fourth plus 2e to the x minus 2 over root x. The next one, you have hx equal to x squared times x squared minus 3x plus log 2. In this case, before we begin differentiating, so you get x squared times x squared, so it's going to be x to the fourth minus 3x cubed. So you must multiply this guy into this product first. Okay, so you must multiply this guy to this guy, and you get x to the fourth minus 3x squared, and you have plus log 2. Okay, so you have s prime x equal to 4x cubed minus 9x squared, and you dip log 2, you get 0. Okay, so you dip log 2, here is a constant. So you get 4x cubed minus 9x squared. Okay, so I teach you slowly here. It's going to be just easy stuff. Okay, and you have kx equal to 2x cubed plus 5x over x squared. So this guy may be simplified into 2x cubed over x squared plus 5x over x squared. This one will become 2x plus 5 over x, and you differentiate k prime. So it's going to be 2, and differentiate 5 over x, so it's going to be negative 5 over x squared. Okay, so that's all. And you have fx equal to x minus 1 over x plus 1. You don't have the quotient rule yet, so in this case, you may have to simplify this one into the sum of many terms of x. So in this case, you know that we're not gonna multiply by conjugate, so we're gonna know that x will be written as x squared minus 1 squared. Okay, so x minus 1 turned out to be square root x squared minus 1 square, and on the bottom guys, so you get square root x plus 1. So in this case, it's going to be root x minus 1 times root x plus 1 over root x plus 1, and you're gonna get rid of these two guys. So it's gonna give you root x minus 1. Okay, and then you're gonna differentiate this one. F prime x equal to, differentiate root x is gonna be 1 over 2 root x, and differentiate 1, you get 0. So it's gonna be 1 over 2 root x. Okay, the next question asks you to find the tangent line to the curve y equal to x squared minus 4 root x at the point x equal to 1. So for the curve x squared minus 4 root x, so you just differentiate. So you obtain y prime equal to 2x minus 4, differentiate root x, so you get 1 over 2 root x. So you get 2x minus 2 over root x, okay? And you're gonna have the derivative give you the slope. So the slope will be derivative at x equal to 1. So it's going to be 2 times 1 minus 2 over root 1. So it's going to be 2 minus 2 equal to 0. So you have the line that has slope equal to 0. That's fine, okay? And we will need one point. So we will need one point on this line. Point will be y at 1. Okay, so point will be y at x equal to 1. So you get 1 square minus 4 root 1. So it's going to be negative 3. So the point will be 1, negative 3. So you get the equation of the line to be the point slope form. So it's going to be y plus 3 equal to 0, x minus 1. Okay, so you basically get the constant line y equal to negative 3. And for the line y equal to negative 3, you gonna know that this one will give you the thing that called horizontal line. So this one shoot like this. So you have your y, you have your x, okay, and you're gonna have y equal to negative 3, which is this horizontal line. So it's gonna be y equal to negative 3. So you get negative 3 like this. Okay, so this one will be just the line y equal to negative 3 horizontal line, slope equal to 0. Okay, when you have slope equal to 0, you should think that you get horizontal line, which is a constant line. Okay, the last one for this topic, we like to find the point on the curve where the tangent line is horizontal. So for the tangent line is horizontal, what does it mean? It means that slope equal to 0. Okay, so when you have the tangent line is horizontal, it's going to be the slope equal to 0. So you will need, we like to find x such that derivative equal to 0. Okay, so we're going to find x such that y prime equal to 0. So you get y prime equal to 3x squared minus 6x. Okay, so you differentiate this guy to times 3 equal to 6. So you have 3x squared minus 6x equal to 0. And then what? And then you're gonna factor x, factor 3x. So you're gonna get 3x, you're gonna have x minus 2 equal to 0. So you solve for x, so it's gonna be x equal to 0 and x equal to 2. Okay, so in this case, you're gonna get 2. Yeah. So I'm gonna draw you something that you have x equal to 0 and x equal to 2 for this kind of slope. So the graph that you are having here is gonna look like this. Okay, and you see that you have the tangent line at 0. okay? And you have the tangent line at 2 that are horizontal line, okay? So you have 0 and you have 2. So they are horizontal line. So the graph look like this one, okay? And we're gonna study like a local maximum, local minimum for this graph uh, in the application of the derivative also. Okay, so this one will be the thing that call horizontal tangent line. The next one I'm gonna introduce you to the product and the quotient rule. For this one, it's gonna be first we're gonna do the derivative of this product. The way to do the derivative of this product will be you may be able to just see that this guy turned out to be a minus b times a plus b. So it's going to be a square minus b square. Okay. So in this case, you're going to just multiply this one out. So you have 4, not 4, let me write down step by step. So it's going to be 2x squared minus 1 squared. So it's going to be the dx of 4x squared minus 1. And this guy has derivative equal to 8x. Okay, so it's going to be 8x. And you have the derivative of the product. And the next guy is the product of each derivative. So you're gonna see this one as the product between the pink guy and the yellow guy. If you multiply this one first and then differentiate, you're gonna get 8x. However, if you differentiate the pink guy and the yellow guy separately, and then you multiply them, the thing that you will get will be different. So in this case, you differentiate 2x minus 1, you would get 2. You differentiate 2x plus 1, you would get another 2. So for this one, you get 2 and you get 1. So you get 2 like this. So the total for the derivative turned out to be 4. Okay. And you see that these two guys are different. Okay, so these two guys are not the same. You're not allowed to dip the pink guy multiply with differentiate the yellow guy. Okay, it's not happen that way for the product rule. Now, if you try to differentiate the quotient between two functions, so you see that this guy, when you simplify, it's going to be d dx, and it's going to be x cubed over x squared plus 1 over x squared. So it's going to be d dx of x plus 1 over x squared. So in this case, you differentiate this one, you get 1, and differentiate 1 over x squared is going to be 1 over x. Okay, so this one you have derivative equal to 1 minus x squared for this function. Again, this one is the quotient between the pink function and the yellow function. And if you find derivative of the pink function and the yellow function directly, in this case, you would get d dx of x cubed. Okay, so d dx of x cubed on top, you would get 3x squared. And d dx of x squared, you would get 2x. So basically, you would get 3 half x. So this one come from the pink one, this one come from the yellow one. And these two guys are again different. Okay, so you have derivative of the quotient of the function is not equal to the quotient of derivative. Okay, so this is what you have. So the thing that we will use in order to differentiate the product of function turn out to be the thing that called the product rule. So the product rule turned out to be when you have the product between f and g like this, you will use this formula, it's called the product rule, in order to find derivative of the product. So it's going to be the first function, which is the f function. So it's going to be the front function or the back and the back function. So you have the front and the back function. Normally, I'm going to say the first function derivative of the second function plus the second function derivative of the first. So it's going to be the first derivative of the second plus the second derivative of the first. And this one is called the product rule. Okay. For example, you get x squared multiplied with sine x. So in this case, you're going to have the first derivative of the second plus the second derivative of the first. Okay, so you have the first derivative of the second plus the second derivative of the first. So this is how we write the product rule. And then you see that most of the time you're gonna get two derivative to phi, so it's gonna be dip psi and dip x squared. Okay, so you get x squared and dip psi you get cos, okay, and plus psi x, okay, and dip x squared, you get 2x. Okay, so it's gonna be x squared times cos x plus psi x times 2x. The second one, you get d dx of e to dx plus 2.5, okay, e to dx plus 2.5. Let's try to differentiate this guy. So you have the product between the first parenthesis and the second parenthesis. So in this case, it's gonna be derivative of the first derivative of the second plus the second derivative of the first. Okay, so in this case, you get the yellow guy and the yellow guy here and the pink guy and the pink guy. Okay, so it's going to be e to the e to the x plus 2.5. Okay, multiply with d dx of 2x minus root x plus the second, which is 2x minus root x derivative of the first. Okay, so in this case you would get this guy and this guy to find the derivative of the function, and then you're gonna differentiate this guy. It's gonna be what? It's gonna be 2 minus 1 over 2 root x. Okay, and the next one here is gonna be just e to the x plus 2.5. Okay, and you're gonna multiply e to the x plus 2.5 and 2x minus root x out. Okay, so this is how we have derivative of the function. By the way, let me teach you about two terminologies. The first one will be derivative. Derivative is your y prime or your f prime x. Okay, and this one is going to be now. Okay, and the action to go from y to y prime here is going to be called differentiate. So this one is going to be verb. Okay, so this one is going to be verb. So the action that we have the function y and we obtain derivative. Okay, so this one is function and this guy is derivative. Okay, the action that we are using is going to call differentiate, or we're going to just say it in short, diff. Okay, Diff here is come from differentiate. Okay, so it means that you are using the formula of derivative in order to find the derivative of the function. We're gonna say that it's called differentiate. Okay, so it's called differentiate. The next one is about the quotient rule. Okay, so the next one is about the quotient rule. The quotient rule here is going to be just you have derivative of two function. Again, you have the top function and the bottom function. Okay, the quotient rule say that when you like to find derivative of the quotient between two function, it's going to be the bottom derivative of the top minus the top derivative of the bottom over the bottom square. Okay, so this one is going to call the quotient rule, and it's going to be another important rule. By the way, I forgot to say that you see that for the product rule, you're going to see that you have two lines. In this case, the first line is called the product rule. I'm going to say that this line is the product rule. And the second line is you diff. So you go from this, you have to use the product rule in order to have this line. However, for the second line, it's come from differentiate. Okay, so normally I will tell my student that the product rule will be just the formula. Okay, product rule is just the formula. So you first put into the product rule the first derivative of the first derivative of the second plus the second derivative of the first. This one I normally say that you put in terms of the product rule, and then you differentiate the term that you have left. So it's going to be you need to dip psi, you need to dip x squared. So they are going to be just two derivatives left to differentiate. Okay. So like the quotient rule, it's going to be the same trick. So you're going to have derivative of the quotient between two functions. It's going to become the bottom derivative of the top minus the top derivative of the bottom over the bottom square. So in this case, you're going to have the top derivative of the bottom and the bottom here. Okay, I'm gonna do step by step for this one, only for this question on this page. Otherwise, I'm gonna not use, I'm gonna differentiate it in a normal speed. So it's gonna be just, I'm gonna differentiate by just using this formula directly. Okay, so in this one, you're gonna have to write down first, put into the product rule. So it's gonna be the bottom derivative of the top minus the top derivative of the bottom over the bottom square. So it's going to be 3x plus e to the x square. Okay, so this one like this. And then you just have 3x plus e to the x. And you see two terms. Let me highlight this one. This one is the bottom derivative of the top over the bottom square. Normally, I should emphasize on square here. You have square here. Okay, and don't forget square here. And the thing that we also have will be this pink guy and this pink guy. Okay, and then you have two derivative in order to differentiate. So you're gonna get this guy and this guy to differentiate. So you would get 2x minus 1 plus x squared, and you have 3 plus e to the x over 3x plus e to the x square. Okay, so this one will be the quotient rule. The next one will be dip tan. Okay, dip tan is going to be, you have to know also that what is tan x. Tan x is equal to sine x over cosine x. Okay, and this one become sine x cosine x. Okay, and you have dip sine over cosine is going to be the bottom derivative of the top minus the top. So it's going to be sine x derivative of the bottom. So it's going to be dip cos x, and this guy is over the bottom square. Okay, so we put this guy in terms of the quotient rule. Okay, so we and then we're gonna have to differentiate sine. Okay, so and then we're gonna have to differentiate sine and differentiate cos in this case. So what we get is gonna be cos x. Okay, dip sine you also get cos x. Okay, so let me highlight the blue color here. Okay, so dip sine you get cos, and you have sine x, and you dip cos you get negative sine. Okay, so you dip cos you get negative sine x. So this one should be the green one. Dip cos is negative sine, and it's going to be over cos square. So in this case, you get cos x minus sine x over cos square. So in this case, you would get cos square x minus become plus sine square x over cos x square. So it's gonna be cos x square, and this one will become 1, right? So cos square plus sine square will become 1, and you have over cos x square, and 1 over cos x square is turned out to be 1 over cos x square, and this guy will become identity sec square. Okay, so you have dip tan equal to secant square. Okay, so this one we're gonna memorize it as dip tan equal to secant. Okay, the last one you asked to differentiate cot x. It's gonna be the same thing. Okay, let me enlarge this one. I need more space. So this guy will become ddx of cos x over sine x instead. Okay, so this guy will become differentiate of cos x over sine x. And you will put this guy in terms of the quotient rule. So it's going to be the bottom derivative of the top minus the top derivative of the bottom over the bottom square, the bottom square is sine x square, okay? And you see that this guy will be, you need to differentiate two terms here. So it's gonna be this guy and this guy. So in this case, gonna be sine x and dip cos is negative sine x. And you have cos x dip sine, you get cos x over sine x square. So this guy become negative sine x square minus cos x square over sine x square. And you see that on top, this guy will become negative 1 over sine x square. Okay, like I used before, cos square plus sine square equal to 1, right? So in this case, you would get negative 1 over sine square. So it's going to be negative 1 over sine x square. And this guy will be negative cosecant of x square. Okay, so you have a formula for differentiate cot. In this case, it's going to be dip cot x equal to negative cosec square. Okay, so you have dip cot equal to negative cosec square, and you have dip tan is sec square. Okay, so they are two trigonometric formula. So this one come directly from just use the product rule. Okay, so this one you have dip tan is sec square. You don't need to show your work after this. Okay, I'm gonna show this one only once, and we're gonna refer to this one all the time. Okay, dip tan sec square, dip cot negative cosec square. Okay. Okay, so for the last two pages on this topic, we're gonna talk about derivative of the function in the given point. So for this one, it's gonna be kind of important for you to calculate the number. Okay, so in this case, we're gonna differentiate this one. Okay, so in this case, we're gonna first find derivative. So we're gonna differentiate first, differentiate, and then you're gonna put x equal to a into fx. So you're gonna put x equal to a in f prime x. Okay, so the solution will consist of two steps. Okay, the first one will be you differentiate with respect to x, and then you're gonna put x equal to the given a. The first one first. Okay, so you have fx is a product between two functions. I'm gonna use the same color. So you have the pink color and the yellow color. So you have the pink one and the yellow one like this. I'm gonna differentiate this one. Okay, so you get f prime x equal to the first x squared plus cos x derivative of the second minus sine x prime, okay, plus the second, which is 3x minus sine x derivative of the first, so it's going to be x squared plus cos x prime. Okay, so you see that you need to find derivative of these two guys. So you need to find derivative of this guy and this guy. Okay, so you need to find derivative of these two guys. So you're gonna get derivative. Okay, so for this one, it's gonna be x squared plus cos x, and derivative of 3x is gonna be 3 dip sine, you get cos x, okay, plus is going to be 3x minus sine x, okay? And dip x squared plus cos x is going to be 2x. Dip cos is negative sine x, okay? So for this one, you get here, here, and here, and here, okay? So this one will be derivative that you're looking for. Let me use other color. I use the blue one. I use the blue one here. Okay. And then you're gonna plug in x equal to pi. Okay. So now you're gonna put x equal to pi. Okay. So you're gonna put x equal to pi. So you have f prime pi equal to pi square plus cos pi 3 minus cos pi plus 3 pi minus psi pi, and you have 2 pi minus psi pi, okay? And you have cos pi equal to negative 1 equal to negative 1 and psi pi equal to 0, psi pi equal to 0. So you would get, okay, so you're gonna get pi square minus 1 times 4, okay, and you have 3 pi multiply with 2 pi, so you get 6 pi square, okay? So this one is your answer, or you may simplify this one to be 10 pi square minus 4. Okay, so this is how we do this example. Okay, so this one will be putting x equal to pi at the end. The next one, okay, the next one I'm going to use other color. You have gx equal to 6 tan x over 2 minus x plus e2 dx. Okay, so you have g prime x equal to, okay, so you have the bottom derivative of the top minus the top derivative of the bottom, and everything will be over the bottom square. So in this case, it's gonna be 2 minus x plus e to the x square, okay? So in this case, you would get, okay, in the case you would get, what should I say? So you need to differentiate two terms. Let me circle them first. I need to differentiate this guy, and I need to differentiate this guy also. Okay, so you get 2 minus x. Okay, so it's going to be 2 minus x minus e to the x, and you have 6. Dip tan is secant square, that's what we just have. Okay, and you have minus 6, okay, tan x, and you differentiate 2 minus x, so it's going to be 0 minus 1, and differentiate e to the x, it's e to the x. Okay, so this guy is the red guy. And this guy is the red guy. Okay, and you're gonna have everything is over, okay, the bottom square. Okay, so it's gonna be 2 minus x plus e to the x square. Okay, so this one is the derivative, and you're gonna put x equal to 0, so you get g prime 0 equal to 2 minus 0 plus e to the 0, and you have 6 secant square 0 minus 6 tan 0, and you have 0 minus 1 plus e to the 0. Okay, and on the bottom, I hope that is not going to be 0. So it's going to be 2 minus 0 plus e to the 0 square. Okay, so in this case, you know that tan 0 equal to 0, so it will be disappear, and you have secant of 0 equal to 1. Okay, so you have secant 0 equal to 1. So this term turned out to be 1. And you have e to the 0 equal to 1. So in this case, this will be 3 times 6, right? 3 times 6 minus 0 over the bottom turned out to be equal to 1. So it's going to be 3 square. So the derivative is equal to 2. Okay, so this one will be your final answer for this derivative. Okay, let's go to the last example for this script. So you have f2 equal to 3, g2 equal to 4, f prime 2 equal to negative 2, and g prime 2 equal to 7. Okay, the question asks you to find h prime 2 if you have hx is product of fx and gx. Okay, so in this case, I'm gonna so in this case, I'm gonna find h prime. Okay, so it's gonna be h prime x. So it's gonna be the first derivative of the second plus the second derivative of the first. Okay, and you have h prime 2 equal to f2 g prime 2 plus g2 f prime 2. Okay, and then what? And then you're gonna plug in f2 equal to 3, g prime 2 equal to 7 directly here, plus 4 times negative 2. So it's gonna be 21 minus 8. So it's gonna give me 13, right? Okay, so this one quite simple. The next one will be take a lot of space here. So you have hx equal to the quotient. Okay, so the quotient between the gx over 1 plus fx in this case. So you're gonna have h prime x equal to, okay, so it's gonna be the bottom. Okay, so h prime x is gonna be the bottom derivative of the top minus the top derivative of the bottom over the bottom square. So it's going to be 1 plus fx square. Okay. So in this case, you're going to have 1 plus fx g prime x minus gx f prime x over 1 plus fx square. And then you have h prime 2. Okay, so you're gonna plug in. So it's gonna be 1 plus f2 multiplied with g prime 2, g2 f prime 2 over 1 plus f2 square. And this guy will be 1 plus f2, 1 plus f2, so it's going to be 1 plus 3, g prime 2, so it's going to be 7, okay, and g2 is 4, and f prime 2 is negative 2, okay, and it's going to be 1 plus 3 square. So in this case, on top, it's going to be 28 plus 8 over 4 square. So it's going to be 36 over 16. So it will be equal to 9 over 4. Okay, so this one will be your final answer. Okay, so that should be all of the thing that we have. So we cover already. We cover the sum, the difference, the product, and the quotient. Okay, so they are will be all of the thing that we should know for derivative of the function. Okay, and you're gonna see that we have some question that is gonna ask you to use the product rule, use the quotient rule. So in this case, the product and the quotient will be important tools to you to differentiate the function. Okay, so we have many formula already. In this video clip, we also dip tan. Okay, dip tan is sec square. Dip cot is gonna be negative cosec square. Okay, I will end this video with the final two formula. Okay, so we already have dip psi equal to cos. Dip cot is negative psi. Dip tan is sec square, and dip cotan is negative cosec square. So we have dip sec is sec tan, and dip cosec is negative cosec cot. Okay, so in order to find dip sec, I'm gonna ddx of sec x, and dip sec in this case is 1 over cos x. Okay, and you differentiate by using the quotient rule. So it's going to be the bottom derivative of the top. Okay, so I'm going to dip 1 plus the bottom, which is 1 derivative of the bottom. So it's going to be dip cos. Okay, so it's going to be the bottom derivative of the top minus the top derivative of the bottom over the bottom square. So it's going to be cos x squared in this case. And you see that dip 1, for dip 1 is going to become 0. Okay, so this guy is equal to 0. And you dip cos, you get negative psi. Okay, so dip cos, you get negative psi x. And I make mistake here, right? So this guy should be minus psi. Sorry about that. Okay, so it's going to be the bottom derivative of the top minus the top derivative of the bottom over the bottom square. So this will become negative become positive. So it's going to be psi x, okay, and over cos x square. So in this case, you're gonna have ddx of sec x, okay, ddx of sec x is gonna be sec over cos square, so it's gonna be 1 over cos x psi x over cos x, so it's gonna be sec x tan x. Okay, so we're gonna memorize this thing as dip sec equal to sec tan. Okay, dip sec equal to sec tan, and you're gonna have the last formula, which is dip cosec. Yeah, you're gonna dip cosec x. So dip cosec x is gonna be d dx of 1 over psi x. So it's gonna be the bottom again, derivative of the top minus the top derivative of the bottom over the bottom square. And you see that derivative of 1, derivative of psi. Okay, so you differentiate 1, you get 0, you differentiate psi, you get cosine x. Okay, so basically you would get negative cosine x on top, and you have sine x square on the bottom. So in this case, you will get d dx of cosec x equal to negative 1 over sine x, and you have cos x over sine x. So you get negative cosec x cotan x. So this one will be dip sec is sectant and dip cosec is negative cosec cotan. Okay, so that all. Okay, next times we're gonna talk about higher order derivative, and we're gonna talk about the thing that the most important technique for finding derivative is gonna call the chain rule. Okay, so I'm gonna stop here. Okay, please recall you have to be able to use the product rule, you have to be able to use the quotient rule by your heart. Okay, so you have to know that the first derivative of the second plus the second derivative of the first, and the quotient rule is you have to be able to use the quotient rule, the bottom derivative of the top minus the top derivative of the bottom over the bottom square. Okay, so that's all you need. Okay, so thank you for this one.